and all gentlemen. My name is Johan van Rooyen, and today I'm going to present to you a summary of my honours project, namely, determine the hand geometry authentication potential of the leap motion controller. To set in motion this presentation, I'll begin with a brief introduction to the core project concepts. These are the leap motion controller, hand geometry authentication, and the KNN classification technique. The purpose of this project is to study certain unique capabilities of an innovative device called the leap motion controller. With this controller, a user has the ability to communicate with the computer by using hand gestures. The controller does this with surprising accuracy and can track a person's hands in real time at up to 200 frames per second. Gestures are recognized by the leap motion software and translated to commands and instructions for the computer to follow. Specific to this project, the controller also has the ability to provide certain hand geometry measurements of a person's hands. Hand geometry authentication is based on the concept of using the geometric shape of the human hand to verify the identity of an individual, such as the size of the palm, the length and width of the fingers, or the distance between the knuckles. To ascertain the accuracy of the data that the leap motion controller can produce, a custom KNN algorithm will be implemented to attempt to classify individuals based on their hand geometry features. The KNN algorithm is a non-parametric classification technique, which this means that it assumes there exists no dependencies in its training data. The classification will typically be the individual's identity. The research question for this project is therefore, can the leap motion controller be proven to be a viable user authentication device by identifying individuals based solely on certain features in their hand geometry? To answer the research question, the following general aims can be described. To develop a hand geometry data extraction application for the leap motion controller, and to develop a custom KNN classification method to process the extracted data, and then to obtain and analyze the results and draw conclusions. The aims will be completed with the help of the Microsoft Visual Studio 2013 development package, as well as the Microsoft Excel 2013. The project was started within the Windows 7 environment and was later completed within Windows 10. The first section to be discussed is the methodology and methods. The software development lifecycle that was used for the development of the artifact was the spiral model. The spiral development model was proposed by Boe as a software development process based on refinements of the waterfall model. The custom KNN method that was developed works in the following manner. Extract the current user's data. Then read the data file and populate certain arrays. Alternatively, compare array values with existing users' data. Result values are stored in a separate array. The separate array is then sorted, and then a weighted scoring model is implemented where the low values are equal to the nearest neighbors and therefore assign a higher score. The high values are equal to the farthest neighbors and that is therefore equal to a lower score. The list of people is then finally returned and sorted by this KNN score. The largest score is equal to the nearest neighbor. To give a brief overview of the artifact, the first part involves determining accuracy, with the statistical analysis of the data extracted by the leap motion controller. The statistical analysis methods are the variance of data measurements and the standard deviation of the data. The second part uses the custom KNN method to determine the consistency of the measurements, which the leap motion is able to extract from a person's hand. The measurements that will be collected by the controller are those of each finger's bones, or more accurately, the phalanges. These include the metacarpal, the proximal, the intermediate, and the distal phalanges. Note, it should be noted that the thumb, however, does not have an intermediate phalanx. The following part of the presentation will introduce an example of the artifact. Next is the results. The results can be divided into two parts: the performance metric calculations from the second part of the artifact, and the raw data analysis done in Microsoft Excel, as described in the first part of the artifact. The performance metric calculations show the false acceptance rates of 3 scans done on 3 individuals. During each scan, the KNN algorithm attempts to identify an already registered individual based solely on their hand geometry data. The second section of the results show the variance and standard deviations of the measurements. The table on this slide shows only the combined statistics of both males and females. After the analysis of the results, the following remarks could be made. The performance metric calculations showed a clear increase in the FAR values as the dataset increased in size. The KNN algorithm became confused between users whose measurements were particularly close together. Considering raw data analysis in Microsoft Excel, the variances and standard deviations increased when combined, but remained small in separate gender groups. They could also not be compared with a similar situation to determine trends, but the FAR values did indicate that the measurements were not adequate. To provide a concise conclusion to the project, it can be used that the FAR values indicate inconsistent measurements received from the controller. The variances and standard deviations support the indication that data extracted from the loop motion is highly inconsistent. It was also found that during the general operation of the loop motion controller, they tended to produce very sporadic data. Therefore, the loop motion controller is not sufficiently accurate to be a viable, standalone user authentication device. This being said, the loop motion controller does still possess a high level of accuracy at tracking the user's hands and remains a creative and original approach towards human interaction with computers. And there are still numerous imaginative as well as practical applications for the controller beyond security. The only limitation to its possible applications is the creativity and inspirational motivation of developers. Thank you.